I want to go past it and bring my play of my screw going clockwise again from where I'm standing. That's a habit I've always had, and you need to keep those things consistently going that way. Okay, we're going to be going through this. This can turn a little bit faster than the other one. The smaller the drill, the faster the RPM relative to previous ones that we did. We want to give the chips a chance to clear out. We're going to squirt our coolant in there. It's a water-soluble oil. It's biodegradable. You always want to do the environmental thing there, which is good. We'll be through here in a second. Okay, that one's through. That's a 13/30 seconds hole. The decimal equivalent of 13/30 seconds is 0.406. It's 406 thousandths of an inch in diameter. Now, some of you guys watching this might already know a lot of this, okay? I hope you do. If that's the case, and you've got somebody you're working with, show them what to do. I learned the trade from people that showed me what to do, so you should do the same to people that are learning behind you. I know there's always the concern, oh, that guy's going to take my job away. Well, there's plenty of this kind of work out there to do. And so encourage one another to do that work and share it with each other. That's the whole premise of what I'm doing here for you guys. I want you to, guys and gals, I want you to learn this, how to do these operations here. It's not going to do me any harm or any good to have you learn. And it's a critical vocation that we're doing here. Okay. I got a countersink in here. That's a big tool that puts a taper on a hole for a flathead screw. We'll talk about what flathead screws are. I kicked this back into low speed again. So I'm going to turn this on the other way. It's got to go in a certain direction. And I'll go down now and I don't have a brush here. I'm going to turn the RPM up a little bit here. We want this guy to go down here. We'll talk about the fasteners that go in here in our recap, what kind of screws go in all these various holes, what they're used for. This is a chatterless countersink, I guess you could call it. Sometimes the way they make these countersinks, there's 6 flutes on this one. They're all even. And if you get a difficult cut going, it starts chattering and bouncing. So some guy had a bright idea to come up with a countersink that had the cutting flutes not equal. That way it doesn't chatter. Okay, on the print it says here, drill 13/30 seconds, countersink for a 3/8 flathead screw. The whole point of a flathead screw is there's 2 things that a flathead screw does. It will hold the block down accurately, and you also want the head of that below the top surface, because if this block has something sliding on it, the flathead screw will be down below the head of that, below the surface there that you're working with. So it doesn't interfere, it holds tight. Flathead screws are almost as good as a dowel pin, which we'll be talking about in a minute. Okay, hole number 2 is finished. Next one here is a same size drill. We're going to drill and counter bore a hole. Excuse me. So we got to move it back an inch. 2, 4, 6, 8, 10. Go past. I'm coming up to 3 inches here. That's my location. I don't know if you can see the digital readout on here. I'm right on 3 inches right there. So I'm going to put my 13/30 seconds drill back in here. 13/30 seconds is 0.406. Just so happens that 0.406 is, we're going to put a 3/8 screw in here. It says drill and countersink for a 3/8 screw, which we just did. Here we're going to drill and counter bore for a 3/8 screw. Socket head cap screw, that is. That's the kind that uses an Allen wrench. A flathead screw also uses an Allen wrench. A little different size Allen wrench. But my point is, we're drilling a 13/30 seconds hole here for a 3/8 screw, or mainly any screw, Anywhere I'd say between 1/4 inch and 3/4 of an inch, you drill a hole that's 1/32 of an inch bigger than the screw. Okay, so a 3/8 screw, 3/8, if you look on your handy dandy decimal equivalent chart, is 0.375 in diameter. That's 3/8 of an inch, 0.375. So a 32nd more than 3/8 is 0.406. And I told you before, the decimal equivalent of 1/32 is 0.031, if you remember. Well, if you take 0.375 and add 0.031, you've got 0.406. I mentioned in my first video that we could get bogged down with a lot of this information here, and I'm bogging you down right now with the details of decimal equivalents. But we'll talk about that in a separate video. But standard drilling for a clearance for a screw is a 32nd oversize in most cases. Okay, I got to turn this back to the higher speed again. Whoop, gotta go the other way. I got it going backwards. You see that? Okay, we're going to come down. I'm going to slow this speed down a little bit here too. Okay, we're going to drill this 13/32 hole again through there. I could have probably drilled this hole before when I drilled the last hole by moving over an inch. That way I wouldn't have had to change drills, but that's the way it is. Yeah, we're almost done with this block. We're on the halfway point of the hole, and the next two holes are pretty simple. They're just smaller holes with a little bit different operation on them. See that chip flying around there? This squirt gun here shoots past the chip, so those chips are sharp, so you got to be a little careful with it. You notice we haven't even taken this part out of the vise. So it's held in position. If you take it out for every time you drill a hole or move it around, that takes time to take the chips and clear them out. I'm doing a lot of jawing here while I'm doing this, so we would have had this block done a long time ago. But I'm talking too much here, but gotta tell you the particulars here. Okay, this is called a counterbore. It's gonna drill a hole that's a pocket for a socket head cap screw. I should have had some screws over here, but we'll talk about those in another video, the fasteners that we use here. I'm going to slow this thing down again here to the back gear. And this has got a variable speed spindle, so you can hear it winding up faster as I go. And another reason we drill 32nd over is these counterbores have a pilot on that goes in the hole, and it's made to fit in a hole that's a 32nd over. Okay, so now, how deep are we going to go with this? It just so happens that a 3/8 diameter screw, a socket head cap screw like you use an Allen wrench on, a 3/8 diameter screw, the head of the screw is also 3/8 diameter. Okay? So what we're going to do, we're going to come over here. I can cheat because I got this digital readout here. I'm going to set the Z at 0. And so for a 3/8 screw, we drilled a 13/32 clearance hole. We're also going to go 13/32 deep with the counterbore. Wrong way again. Okay, so I set the Z at 0. We're going to go down to 0.406. Or more. You want the head of the screw to be below the surface. You don't want it sticking up. We're at 350, 370. We can go a little bit deeper. I want about 420 deep. That's good. The head of that screw will be forever below the surface of our block. Maybe something has to bump against the top of that or slide over the top of that. I don't have a brush over here, or a rag. I need a rag to clean this off. Can't see what we're doing here. Okay, 3 of these holes are done. Next hole. So we're going to move back another inch. 2, 4, 6, 8, 10. Bring it back up to 2 inches. Go in the clockwise way, as always. Again, anybody that doesn't have a digital readout on your machine or a CNC control, it's an old screw and a bronze nut. and there's play in it. You could have up to 30 thousandths play. If you didn't have the handle, the play going the right way, you could end up putting your hole 30 thousandths off. Okay, so our next hole here is going to be a reamed hole. Got to drill a 19/64 hole. Let me grab that drill. 19/64. Here we are. 19/64 is 1/64 less than 5/16. We're going to ream a 5/16 hole in here. So what we do with the reamer, a reamer's this tool right here. You can see it. There's a bunch of flutes on here. A drill's got 2 flutes. Our counter bore had 3 flutes or 4 flutes. Some of them have. This reamer here's got 6 flutes. But the reamer, we have to put a smaller hole in there, and then this reamer will go and make a hole exactly 5/16 of an inch in diameter. Now you might wonder, it's 5/16? It's 5/16. But if you look on your chart here again, you're going to see 5/16 right here. That is 0.3125 is the diameter of the 5/16. And the reason we're going to put that in there is because we're going to use a dowel pin in that hole for maybe mounting this block on another plate. Now I'm going to drill the hole first. So we're going to kick this back in higher gear. Now this is a smaller hole. 5/16 is smaller than 3/8, and we're just under 5/16 for our drill size. Going the wrong way. Going way too fast, so we're going to slow this guy down. We'll get into the RPMs and whatnot for drilling different size holes as we go along here too. That's another important topic. You can't run a big drill at a high RPM. You'll melt the drill and the piece that it's drilling a hole in. So everything's got its right speeds and feeds. That's a big part of machining. Different speeds. Or not just necessarily drills or reamers. When you're on the lathe, you can do some heavy cutting, but you have to slow the feed rate down. So speeds and feeds are a critical thing. We'll be talking about all that in subsequent videos here. Okay, our hole is drilled. Now we have to ream it. I was saying a drill's got 2 flutes in it. Here's the end of that drill. You can see there's 2 flutes there. The reamer has 6 flutes, so